So welcome to the developer meeting on Sunday, the 5th of February. And just two quick updates on the enclosures. Enclosures are sent from, 8 enclosures are sent from the UK to Austria for further shipping. And there's a little hiccup. It was sent to the wrong address in Austria, so we lose a more couple of days until it will then be reshipped worldwide, also to the destinations. And the last thing is on the adapter for the camera and the optic. Oliver is working. We have 3 candidates for now. They differ a little bit. Oliver is now optimizing them for having a common setup for 3D printing anywhere, with any setup in the world, so that we have a working adapter that anyone can print, and you just have to attach your camera and your optic and just screw them on. So that's the idea. With these notes, I'll hand over to Ido.
Yeah. Hi everyone. Let's start. Yeah, let's start with some updates. David, Mike, we'll start with you guys.
Yeah, so I can probably give an update. So I've just been integrating some of the stuff that David's been working on. I've been integrating into the tracker. So currently I've got the cloud estimator as well as the day-night classifier. So those two items have now been integrated into the observer node. I'm just doing some refactoring at the moment to make it easier to do error handling, because I would like to try and put some error handling in the main processing methods of the nodes. Just because currently if there's an error, it takes the node down, and I kind of don't want it to do that. Yes, the next thing on my list is there is a like a sun and a moon mask, and I would like to get those. That's what David's been working on as well, so I'd like to get those integrated into the tracker. And then also I need to at some point start looking at exporting data out into Prometheus and Grafana and all that sort of stuff, and profiling it, and so that's kind of where I'm at the moment. And QoS, so QoS is on my to-do list this coming week as well.
Cool.
And that's pretty much me.
Okay, nice. Lionel, any updates from you?
I'm happy to. Sorry,
Yeah.
I'm happy to.
Yeah. So I'm trying to make some prediction on the stream of coordinates of tracks that are coming out of the annotated frame provider.
Mm-hmm.
But the problem I'm having is that there's so much data in the stream, and the prediction server that I programmed a node that behaves as a server, and just to bootstrap the node, I think it slows the whole thing down. I think it's like blocking other threads. That's a feeling I have, but do you think it's possible?
That sounds weird.
Yeah.
Python is a single-threaded environment, so just be mindful of that. It's something I've run into in the past. Is I'm not sure. Yeah, so I'm a bit woolly as to if we can get multiple threads running in the same node, sort of thing.
But the whole environment, it's a multi-thread. That's for sure. Yeah. Okay.
Yes.
And the init method of a node is only run once when you launch the program. It's not rerun every time.
No, it's just once when you run the node.
Okay. And yeah, also something that I wish I'm happy to be able to chat with you about. So I'll probably work things out why it's so slow. Anyway, the approach I took was to have my node just wake up every 2 seconds. So it's probably not right. But in terms of QoS and time synchronizer, so just the concept. So if I'm a node and I wake up every 2 seconds and I grab the last message, what's the time synchronizer? What is it? Is it a class? What's it gonna do?
So I can probably help with that. Okay, so the time synchronizer is basically it's almost like, think of it as an aggregator. So if you have several messages, okay, coming from if you have messages coming from several nodes, as long as they have the standard header that is defined by ROS, as long as they include that standard header, and that header is populated at source with the time component. So it's populated source with the time component. You can then aggregate those messages into like a single stream again. So you can basically take messages from different nodes and treat them as if they come from a single node, and that is the time synchronizer does that for you. So I'll give you an example. So we get a image feed from so hypothetically we get an image feed from a camera that has got a timestamp associated with it. On that image or frame, we apply a mask that's then published onwards, but we include the header from the initial source, we include in the masked frame. Okay, so the next node picks up that masked frame, processes that frame, tries to find if there's any objects in it. So like, for example, the background subtractor will do the background subtraction thing. We can then also do blob detection. At that point, we then publish the message forward again, but we don't include the frame. We just include if we found an object, we just include that information. So then if we have a third or fourth node down the pipeline that subscribes to both the track information and the masked frame, as long as we included the original header in the track information message as well, we can kind of aggregate those two messages into one, and we can be sure that the data containing the track information is associated with the frame that we have. I'm probably making a bit of a dog's breakfast of trying to explain it. Does that make sense? Or not? Sorry, I'm terrible at explaining stuff, so I'm probably not the best one.
Yeah, it's complicated. But does that mean that if I pick up a message, I'm sure that it's the last message as long as I have that time synchronizer syntax in my node?
It's got nothing to do with that. So it doesn't have anything to do. You can't use it to decide that you want to pick up the last message or a message every 2 minutes or anything. It's purely just synchronizes messages or several messages from several nodes. As long as they have the same timestamp in the header, it synchronizes all those messages into a single stream. So you have all the data that has been published from 5 nodes. You know that all that data is related to frame A. So you can then plot, I use it to basically then plot, you know, the detections and the track information and the projection. All of that stuff comes from separate nodes. But I aggregate all that stuff into one and then plot all that stuff onto the, in the annotated frame provider. I kind of aggregate all that data and I'm then confident that even although I've received that information from several nodes, I know it all pertains to the same frame. Because otherwise, if you don't do that, you can be in a position where you don't know if the data is associated with a frame you've just received, sort of thing.
Okay.
Is that,
So,
yeah?
Yeah, okay. So I think that for what I'm trying to do, I should not really care about the time synchronizer. If I pick up a message, it's the last at that point.
Yes.
Yeah,
So the idea
yeah.
of time synchronizer is actually to buffer up a bunch of messages that are related to each other that you need to process them all at once. I used it a lot in Fusion, right? When you have like two sources, for example, a camera and a LiDAR input. And you need to ensure that the frame is aligned with the LiDAR. So you will time synchronize it, so you process both of them together. Does that make sense?
Yeah. So if you take a look at my screen.
Yes.
So every 10 hertz, I get a trajectory message, and within that trajectory message, everything is going to be organized correctly, thanks to the time synchronizer.
Yes, exactly.
Okay. Okay, so that's all for okay. Okay, and also so at this point, this is not defined yet. We don't play with low priority queues and high priority queues up to this point.
Yeah, for now, leave it as is.
It's still empty. It's blank.
Don't change.
Yeah,
don't change the quality of service. We will have Mike learning it, and then we'll all like work through it together.
Okay, cool. Okay, so so it's been fun to do. Still doing it this week.
Cool.
Yeah, very cool. Very cool stuff.
I'm sorry?
Very cool stuff. It's fun work.
Yeah. Rebecca, do you have any updates? See you here. Rebecca?
Not this week.
Okay, no problem. Okay. Anyone else? Sorry, it's like hard for me to see who is here.
Yeah, can you hear me okay?
Yes, Lionel, yeah. Hi.
Hi, it's David.
David, sorry.
Hi.
Yeah.
Yeah, I've been working on a few things that Mike was kindly turning into proper code and integrating. I can demo a couple of things if you're interested in seeing
Sure.
them. Just to put the idea forward, really, because I mean, a lot of what I've been doing is driven by some issues I've encountered in the past when running background subtraction algorithms just from the camera poking out of my window and recording things in the sky. So I had a Dahua camera I had left over from Skyhub, so I've been recording that and doing some work with background subtraction, but I want to try and come up with a way to help reduce false positives. You get a lot of
Yeah.
Cool. So I thought I'd demo the problem first of all. You're probably familiar with it already, but I'll bring it up now and just hopefully you see this. So this is like what I call an easy case for a background subtractor. I mean, the scene's quite simple. And if objects are moving in a scene like this, like a plane or like a little circle I'm drawing on the screen, it'll be easy to detect and track. But if you have a more complex scene, like this one, what you typically see is things like this, where you get light shining on the edges of the clouds. The foreground mask has got a lot of noise in it, so it's like cloud clutter, if you like. So it becomes a lot more difficult to kind of keep a track of objects, or deciding what objects are important to track. So to get around this, you can use more sophisticated background subtraction algorithms. I'm running Vibe here, by the way. I think Vibe is a candidate background subtractor that you guys have been looking at. Apologies if I'm kind of out of the loop with all of this, but Vibe's quite a sophisticated background subtraction algorithm. Pretty good, I think, considered quite good for ignoring kind of repetitive motion. But basically, more sophisticated models are more demanding. I think they use a longer history of frames to build up a model of a background. So you could use a more sophisticated algorithm, or these algorithms have got parameters, and you can adjust threshold values and find an optimal threshold where it eliminates the noise and retains the pixels that correspond to something that's moving in the foreground that you want to track. But in scenes like this, it becomes really, really quite challenging, because you can see here, this is a lot of kind of noise being built up in the foreground mask. I'll just stop that now. Let's go over to this. So just to kind of illustrate, you can change threshold. So I'll change the threshold on Vibe. It kind of suppresses a lot of the noise, but you see a little moving object, it will sometimes be suppressed as well. So trying to find a good threshold is going to be challenging, I think. So one idea I had was to look at cloud estimation. And this is what Mike's integrated now. But basically, it's just an estimate over the entire frame about how much cloud coverage there is. So coded a Jupyter script, and this is in the repo. You can have a look at this, but it's got 6 images here. Hopefully you can see those okay. So a couple of partially cloudy ones, a couple of really overcast ones, and a couple of clear day blue sky examples. What I'm proposing is that these cloudy, partially cloudy days are going to be the most challenging to deal with, whereas these overcast ones, as long as the object's below the cloud, should be quite easy to track, I think. And these sunny days as well, you shouldn't find too many issues. But to estimate a cloud, you can calculate like a ratio between the blue and red channels. It's called a normalized BR ratio, and this is nothing new. There's a lot of this in the literature about detecting cloud coverage. So I've really just implemented what's out there already. After you get this normalized blue-red ratio, you can get an idea from the whereabouts the clouds are. So if I just leave this up here, you can see the original image. You can compare the darker areas are the clouded areas and the lighter areas of blue sky. So you can see these two overcast days are completely blacked out, and the sunny days are almost white. If you look at the the histogram on these blue-red ratio images, you can see for partially cloudy, what you normally see is like a bimodal distribution. So you get two peaks in the distribution here. On overcast days, you get a single peak down this end of the scale, and then on sunny days, you get a single peak, but up at the other end of the scale. And this could be useful for determining whether it's overcast, whether it's sunny, or whether it's partially cloudy and potentially challenging. But once you've determined this blue-red ratio, you could apply like a thresholding algorithm to derive this like binary mask of the cloud coverage, and then it's a simple matter of just counting the white pixels versus the black pixels to determine the cloud cover. So on those 6 images, I've calculated what the cloud cover is. So first image is 45%, around about. Second, 19% or 20%. Overcast, both 100% cloud cover, and blue sky days, sunny, that's the 0% cloud coverage. And then this one's got a little bit of cloud around. It's got about 6% cloud coverage over the entire area of the frame in the fisheye view. Could do the same thing at nighttime as well. The algorithm is slightly different, but the idea is still the same. You just look at producing like a binary mask of showing where the cloud is, and then we can count the white versus the black pixels, and that gives us a percentage of cloud cover. So the idea was, once you have this percentage, it could play into something like the settings on this background subtraction algorithms, like threshold. So the greater the maybe not the greater the cloud coverage, but somewhere in the middle, on a partially cloudy on a challenging day, you could increase the threshold on the background subtraction algorithm, and that might help a little bit. It's worth trying out anyway. I don't know, it's just an idea. The other thing I did was there's another Jupyter script. I won't spend too much time on this, but the idea is to kind of mask out the sun or mask out the moon, because a lot of the issues occur around the kind of main light sources. So in this one here, it's quite complex. You get quite complex foreground mask. The light spread out across the scene, but in this one here, it's a bit easy to see. You see the moon, and the clouds are passing in front of it, and that is kind of picked up as motion. So having a little mask around the moon, you could potentially improve things, I think. So the script just goes through how I've derived that kind of solar mask. So if you know the location of the camera, if you know the time of day, you can work out where the sun will be and work out where the moon will be, and then put a little mask over it, and that should improve things. But yeah, it's a couple of ideas. It might be helpful, might not be, but the source code's there, and you can. And if there's any questions, fire away.
Yeah, looks good.
Thanks.
I'm familiar with the cloud masking on ASIC. I had that a long time ago. Cool. Yes.
Okay. So yeah, great work, David, and a great summary that you put together. And yeah, that raises the level by some notches, I'd say.
Thanks. The other thing I thought about is maybe you could try and detect when you've got some unwanted things on the camera as well. I mean, if you've got, and detect when it's raining and things like that. If you've got water on the camera, or if you've got some dirt on the camera, you could, if it's occluded in some way, you could try and detect that and put out a warning for or something like that, cleaning the camera or something like that. I don't know, it's just some ideas.
Yeah, we spoke about it last week that we want to have like an environmental kind of stream. So if we know clouds, if we know rain, if we know it's too sunny and the camera is blind, those topics will be useful to like like realign the station to like a better working state. For example, there is no. Yeah, go ahead. Mate.
No. So that's sort of the thing that I've been working with David on. So exactly that. So have this sort of environmental data to say, exactly those sorts of things. Yeah. So that we can, because we can. So it's quite easy to reload nodes and stuff like that. So if we need to change the background subtractor or make parameter tweaks or any of this sort of stuff, it's getting into a position where it's quite easy to do that sort of thing based on actual data that we're receiving from the environment. So that's exactly so that's exactly that.
Yeah. And later on, we can put it into a neural network. So we don't really need to say, hey, this is, when it's raining, use this algorithm. Like let it learn it on its own. See what gets better results.
Yep.
Right. Sweet.
Yeah, that's above my pay grade, mate. So I'll stick with the simple stuff.
Hey, look, it's all about providing the data. It's all about bringing the data to topics and then later on feed it into like a neural network and then just training it, keep training it. This is better, this is better, this is better, or this is worse. And you teach it. So I'm sure by the time we get there, something will be out there. And there is a big push now in the industry. I'll speak more shortly about that.
I was wondering, is there any way to simply remove anything that's moving at a certain speed or less? For example, is there a way to write an algorithm that would remove anything on the fisheye lens that is moving at 5 miles an hour or less, or something slower than the speed of what a cloud would move, and that way just remove everything except an object that's moving faster than that?
Yeah, so in order for you to remove something that moves below a certain speed, you first need to realize that it's moving in a certain speed to begin with, right? That's the calculation that is problematic.
And the speed is an angular speed. That makes it more problematic.
Yeah, yes. And now the speed is also even more because it's a fisheye, right?
Mm-hmm.
So above you is going to be different than on the edge. Yeah. It's challenging. Background subtraction is very challenging. But I hope the experiment that we will do with the one in the camera is going to help a lot with that. We spoke yesterday about it. I forgot his name, Richard. What was the guy name that we spoke with?
Geoff.
Yeah, and he liked that idea also. He said that will help a lot. So hopefully that will do it. Yeah. Any more updates from anyone?
I just have a very quick update. Sorry.
Yeah.
Sorry, Ghost. Just a very quick update. So I'm currently using the Simple Tracker to process mainly Brett's videos.
Mm-hmm.
And in the currently Simple Tracker uses a lot of my PC's resources. So I was just surprised by that. So it regularly freezes and I have to reboot my PC. So I have to increase my RAM actually probably from 16 to 32 gigabytes. And then I can continue with that, I guess, because I wanted to do that while we have the meeting today, but it's not possible because it freezes up my PC. So
interesting. So let's do a few things. First of all, when you run it, monitor the memory and see what's the capacity.
I do that already. You can see when you look in the Hangout chat. You can see. I posted a screenshot which I had to do with my phone actually because my PC wasn't reacting anymore. There you can see it fills up my swap file.
And which channel? Sorry?
Hangout.
Hangout. Okay. Sorry.
The last image. Yeah.
Yeah.
When you look at that, you see it fills up my swap file, and I increase it to 4 gigabyte, but it's still freezing regularly. I wrote that.
Yeah.
You know,
are you running? Okay. Are you running pure on Ubuntu, or are you running it underneath something?
It's pure Ubuntu. It's dual boot system with Windows.
Yeah. So.
So it uses currently up to 16 gigabyte of RAM plus 4 gigabyte of my swap file. So, and sometimes it wants to use more, and then my PC freezes and I have to reboot. So it's kind of difficult right now to make batch processing with videos, which I need to increase my training data set for the kinematics approach. So I probably will buy more RAM and then I check if I can process like in batches, because that will be very helpful for me.
Yeah, you could always try and go down and run a profiler on it and just see if there's something's obviously chewing up memory. So if you want to give that a go and see if you can get a profiler up and running and see, try and determine, because it's just going to save me a job, you know what I mean? Because otherwise I'm going to have to do that. So if it's something that you struggling with at the moment, if you're up for it, and just see if there's a memory leak.
I can try to do some started with that, let's say.
Yeah, I've not done it in Python. I've done it with other stuff, but I'm sure there must be some sort of profiler. It's basically what happens is what'll end up happening is you will almost get like a bit of a idea on memory usage between one frame. If it processes a frame and then it processes another frame, it takes a snapshot like at the point of processing every frame, and then it'll do a comparison and give you a diff as to where the memory's increased. And then if there's an area that memory's increased, and it's suspicious, then you kind of investigate a little bit further. But it's on the to-do list. I didn't realize it's that. It sounds like a pig when it comes to memory. So I didn't realize it was that bad. But
I think the Spider IDE has a profiler built in, so I can maybe try that, or probably there's something like that in Visual Studio Code too, right? So
I would have thought there would be. Yeah, exactly that. So if you want to give it a go, I'd really appreciate that if you'd be up for it, because it just, as I say, it just kind of saves me a job, because otherwise I'm going to have to do it,
I can do that, yeah.
Thank you.
Maybe I can do that this evening or next weekend then.
I
don't know how you do that working during the week for Sky 360. I mean, that's kind of impressive to me. I couldn't do that. But anyway.
Oh, that's why my wife gets grumpy with me, so don't worry.
So if you're working on it tonight, send me a message. I might be able to jump in and try to help you resolve it.
Okay.
So see what's up. Okay.
Cool. Yeah. Thanks.
Yeah. Sure. I love these kind of issues.
Okay. You guys are all them. Linux.
Okay. I think that was pretty much everything from my side.
You guys are all running. Yeah, you guys are all running this on Linux.
Yeah.
And is anybody using a virtual machine, or are you just booting to Linux?
I'm running this on a Macintosh actually.
Okay, so this should run just fine on Windows, running Python, or?
Sure.
Oh, cool. Okay.
Yeah,
well, I think we to run Simple Tracker on Windows, but somehow I couldn't. Then I switched to Ubuntu.
But why don't you all use the Docker container?
Yeah, I was using the Docker container on Windows, and somehow I couldn't get it to run. But maybe I don't know.
Actually, come to think of it, I couldn't get it to run on Windows either.
Okay.
I think it was due to low RAM.
Okay, so I'm a complete Docker noob, so for me it could be anything, right? So
yeah,
I think David. Sorry, I interrupted there. I think David wanted to say something.
Oh no, thanks, Mike. No, I managed to get it.
But I do have another question.
Lionel, hold on a second. You interrupted David. David was about to say something.
Sorry.
1 second.
Hey, no problem. Yeah, hope you can hear me. But I managed to get it running on Windows. Yeah, you just need to install a little piece of software, and the instructions are actually on the repo now. I think Mike's updated the README. I think there's like 4 steps. I just can't remember off the top of my head what they are.
Yeah, I think it's the ROS version of the simple tracker that I updated. I probably need to do the other simple tracker as well. Yeah, I've not updated the README on the other one. I think you need to install like an X server for Windows component, so you could forward on the screen or something.
Yeah, that's it. Yeah, it seems to run okay though once I installed that.
Okay, maybe just one more thing concerning the environmental data. So it's been a while that I wrote a simple script which uses a weather API and calls weather data from that API. So maybe you can make use of that. So just wanted to put that out there. And I'm just copying the link to the repository in the Hangout chat. So in case you're interested, it contains precipitation data and all kinds of weather data that you might be interested in.
Oh,
so
cool.
yeah.
So this is one of the questions I had actually is, do we run in an online mode, or do we have to be able to run in like an offline mode?
So I think we are going to run both, and specifically with the the demand that start to come, that how we share the data, it's becoming more and more online. So that means we should be able to feed the station with environmental data from outside the station, either nearby station, internet, or whatever. Yeah.
So it would be good if we could make a decision on that. So as well. So are we saying that we, like a prerequisite for being able to run the station is it needs to be connected to the internet, or are we saying it doesn't?
It doesn't.
I think we can just go with both scenarios, right? Yeah. So if there is internet, you can use weather data that is called from APIs, and if you don't have internet, then it's basically on you as a stationer to provide additional sensors that can deal with weather data, or otherwise
weather station.
Yeah. Or otherwise, maybe the program, if you don't want to do that, the program just isn't like that good. On the best level it could be, basically.
My setup was going to have it such that the user would say what devices they have and whether or not they want to retrieve the data online if you don't have those devices on the station itself. So the GUI was going to provide a format for people to check buttons or tick boxes to say, yes, I have this device. Please read data from that device. No, I don't have that device. Please, if possible, read that data from the internet, from an API from the internet.
Yeah, we can mix match.
Shouldn't we come to the point where a central node knows what kind of sensor equipment it has? Isn't that part of the robotic system as such?
Yeah. Let's speak about it offline.
Okay. Can I say just one more thing? On a little design document that I did about a month or two ago, I wrote something about that, about how to organize that to get data offline or online. And that's all I have to say.
Yeah. We've seen that.
Nice.
Michael the Ghost wants to say something. Michael, you're muted. Is he muted, or do you hear him?
Yeah,
I can hear
you.
Okay, I have to step out again. So what was the question?
Are you back with us, Richard?
Yes, I'm here.
No. Okay. Now, all I wanted to say was, well, a couple things. One, if we're going to start coordinating, particularly for trying to get some more or less universal standards going, I would love to be, a hanger-on on that. I don't have the time to really be able to spearhead a thing like that. But in the interest of getting accurately reflected in what we're doing, yes, I would like to participate to whatever level I can, just as a point of information there. And the only other thing is, for some reason, you know, Mr. Murphy of Murphy's Law fame seems to really love me. So, you know, I was hoping to be able to ship the ATX power supply adapters by like tomorrow, and everything was going great until I said, well, okay, let's put them up in what's called ASA, which is what I was going to use instead of ABS and that kind of thing. And I'm making these very lovely rocking horses. You know, for some reason they're peeling off the plate wrong when they cool. They look great all the way through, and these things are taking about 11 hours to print. No problem. But as soon as they start cooling, they roll up. Matter of fact, they look, yeah. I don't know if you can see it really well there, but they've got a very nice little bow to them.
Yeah.
You know, and yes, I could, you know, it's the kind of thing I could sand them flat, but then if they were ever used, you know, this would not match to any other plumbing. And so I've tried 2 different things. I'm on a 3rd one to see if I can't get these to print right. But once that's done, and I'm hoping my test case this afternoon, I'll be able to start turning them out. And so I should be ready to send them in about, by Thursday or Friday-ish. So just I want to, you know, make sure that gets out there.
Bless you.
Gesundheit. Or tight gazoons if you prefer.
Hey, just to interrupt you here, Michael, isn't this a heat bed issue? Shouldn't the heat bed then be hotter so that had the plastic more adhesion? Talk with
actually,
or with Wayne about it.
Oh no, I've been looking into that, and I actually think one of the problems I'm having is I'm running it too hot. And so what's happening is the bottom, rather than hardening up when it really should, is staying just soft enough that once the print cycle finishes and it turns off the bed heat, now the whole thing is now ready to start, you know, contracting back in. Whereas if I run a little lower heat, I think I'll be okay on the bed. Okay. If I run a little lower heat there, I think, and that's what I'm going to test this afternoon, it'll be a little cooler, because the other thing is you need to enclose it, because ASA and ABS, they want a fairly high ambient temperature also. So that's what I'm going to test this afternoon. If that goes reasonably well, which every time I think that's going to happen, some new disaster shows up, but that's just life, and that's just life. And so
what are you
anyway,
printing it
but
out
I just want to give you a quick.
What are you printing it out of now? What material are you using right now?
Oh, ASA.
Would you mind sharing the STL
basically,
with me?
Actually, it is on, because they provided to me. I'm just trying to remember exactly where. Let me get back over here somewhere. Come on. Yeah.
I'll try to print it out of ABS and see if it warps for me or not.
Yeah, well, I understand ABS is supposed to be a little nastier, and I think it's on. Wasn't on 3D printing. It was on hard. Let's see if it's an enclosure.
May I interrupt you guys? Maybe it's wiser that you 2 guys go into direct communication. I think it makes much more sense here. What do you think?
Yeah, we can do that. Sorry, I didn't mean to be taking up quite so much time.
I think it makes much more from that point of view here.
Yeah, I've been printing with ABS for like 8 years. So.
Yeah, like I said, so far my ABS results have been really bad. But anyway, the ASA is looking good except for that peculiar problem. So anyway, and that's all I'll say on that at the moment. So and beyond that, a little later, Richard, probably during the week, I want to get with you direct message on some of the things on documentation that we mentioned last week, and just to kind of talk about what I got in mind for format and if it looks viable for for the project. Okay.
Yep, got it.
Fantastic. That's all I have.
Nice. Okay. Cool. Yeah. Go ahead. You're muted.
Yeah, just wanted to say that I'm sharing my screen, and I've been getting that error message kind of randomly since I checked out the main branch. I think it was about Friday, and it's random because I just built only this package. I did not get the error message. And now I just build the entire stuff, and I did not get the error message. But just earlier, so it's the same. I didn't change any code, or so I did the same 20 minutes ago.
Yeah, so something I have to do. So Lionel, just from from past experience, if you on the left hand side, do you mind just on the code editor, do you mind just scrolling up? So what I have to do quite often is I have to delete the build folder, the install folder, and the log folder.
Okay.
So the main one, I suppose, is the build folder, but I would just delete, like when you run into like issues where things aren't consistent and it's behaving a bit strange, I would just basically delete those 3 folders and then rebuild, so it rebuilds it from scratch.
Okay. Yeah, okay, perfect.
So we should create like a make clean command that will wipe this, the build, install, and log. That'd be a good.
Okay.
Yeah, I appreciate it. I've had that problem too, so that's a good answer. Thanks.
Cool.
Yeah, it might not solve the problem, but it's just, I know that it's something that I have to do periodically. Hopefully it helps you guys.
Yeah, I probably will. Okay.
Yeah, building. C++ building. Okay. Any more updates from anyone? No.
I have a question, Ido. I have a question. NixOS.
Yeah.
NixOS it shall be, right?
Yes. So I have an update on that.
Yes. A question before you get the big update. Why not make a Docker? Is it possible to create a Docker container with NixOS inside?
Yes.
Why should we do that so that everyone has the same Docker image no matter what platform?
So we already have the Docker images. I would say the Docker is less important, right? Because I would say, so I got NixOS to work on the NUC, the Intel NUC, okay, and I also have it working on the Pi. I don't have it on the Pi 4. I don't have it on the Orange Pi or the Rock 5B. But those I'm still struggling with. So what I'm thinking, because we are building everything on top of ROS, we only need whatever operating system it is to install ROS on it or Docker and then run everything from there. Okay. And NixOS is the long term. Eventually, these chips will support it, and I will have SD images. But before that, today, just install Ubuntu, install Docker on it, and we will be able to run everything like that. Okay, so that's not a showstopper for anything, really. But honestly, using NixOS inside Docker, it doesn't really make sense to me. It's over complexing a lot of the builds. But technically, you can. I should actually try it. You can create a NixOS, a Nix build that will build you either SD image, update your system, or create a Docker image. Okay, this is something doable. I'm actually planning now for the NUC to create an SD image, but to create a script that will either create an SD image or update the system. So it will have an installer in it also. Okay. Yeah, and hopefully then I can import it also to the Pi 4, so that will work there as well, and we can customize it in the future to other boards as well. But it's a lot of work because there's not good documentation on it. It's really looking at the code of how everything is implemented and figure it out from there. And ChatGPT is not great because it only see until 2021. In next days, it's like ages ago. So it doesn't help too much.
Can you repeat the last sentence? Since 2021?
So ChatGPT knows until late 2021.
Okay.
Okay. Yeah. So that's too old for Nix. Yeah, but the way I work really, I can tell you, I have like now on the so I'm working on the Nuke with NixOS, and on the Orange Pi 5 I have the Ubuntu with Docker and ROS 2. Okay, and that's how I'm actually I actually just finished last night to do it. And my goal is now to finish the camera, SROS 2 node fully working. Okay, so that's kind of my goal for now. But the biggest update, I can't believe I just learned about it last night. I should have seen it like a week ago. But I was busy with this SDSB disaster in the community, really. But ROS was acquired by a company, I forgot the name, Intrinsic. It's a company that is a part of Alphabet, the Google. Okay? And what was bought is really the corporate side of it. So they have what is called Open Source Robotic Foundation, which is the non-profit that keeps the IP and ROS and everything else, all the Gazebo and all the other tools. And then there is the Open Source Robotics Corporation that actually hire all the people that contribute to ROS, and that's what was acquired, right? So one can argue that ROS is now part of Google, right? They kind of deny that, but still, Google was created by Larry Page and Sergey, so they are in Alphabet, so there you go. But what does it mean to the industry, right? So a few things. Number one, Intrinsic is focusing on AI and industrial robotics. They want to simplify it, right? Now, as I said before, ROS has a very good adoption in all the kind of research science side of things, of building robots and modeling really fast, but it has less experience with production environments. So that will take really ROS to the next stage with improving the reliability of it, using it, that should become simpler, and really build something that can go all the way to production. I don't think they will focus on the consumer side, given the company is focusing on the industrial robotics. Okay, but I do believe they will bring AI into the game, and again, advanced kind of UI that you can really plug and play robotic parts and configuring everything, right? So that's really, really interesting, really, really exciting. But it also leaves a lot of room for now companies to attack the consumer side of things. I don't think they will go for that. It's just too much to bear, given the now, probably for the next year and a half, they will need to productionize their system, like ROS 2, really productionizing it. So they will be very busy with a lot of improvement for us that we will be able to utilize under Sky 360. So that's exciting. Okay.
Yeah, don't forget this is recorded. Don't say any more. Don't go any further.
I know. I know. I know. I know. I saw that I got your attention on that. Yeah, but now that you know they kind of separated the federation, the foundation, sorry, and the corporation. I think now the foundation is in a lot of need because some of the people actually moved to the corporate, right, to Alphabet. So it will be a very good time to actually look at ROS, see what their roadmap is, right, and align what Sky 360 wants to do with the you know what they are going to bring. I'm sure that we will know more probably in the next quarter or so. Now they're still like arranging everything. It just happened last week, but that's a very good thing for the open robotics community. Which to me, you know, in 3 weeks we experienced a whole lot of roller coaster in 3 communities. And you know, in open source, everything from you know, God forbid, whatever that I don't want to even say the word, to like you know, just grade last week, and then here you know, a big company is coming and trying to you know, democratize robotics, right? And leaving the source and leaving the open source as open source, not touching it, and actually continue contributing to it, which is amazing.
So I know, may I interrupt you? So this the setup was twofold. It was an open source part with all the IP.
Yes.
And there was this commercial part that was sold to.
Yeah. So the corporate side, they did a contribution, right, to the open source. They didn't hold any IP. And they also, I'm pretty sure they did like a custom project internally. Okay, and most likely now they will focus more on that, what the industry needs, because the adoption of ROS kind of blocked in the industry. It was very hard to convince companies, specifically large companies, to adopt ROS and productionizing it. But now that you have a company that is going to do that, you know, the adoption is going to be a very easy decision. Okay, because you have one with money, and you know, you can pay for a service now to productionize it that you couldn't do that before. Okay, and that will make all the difference.
I see what you're fathoming. You want to buy products from the shelf that are already ROS enabled.
What?
Okay, now go ahead.
No, I couldn't hear you.
Did I say something?
But yes, so this is good. It shows that we're on the right track with selecting ROS. You know, we are in the sweet spot that it's being you know, focused to become like the industry leader for industrial robotics, which is, I would put Sky 360 as one of these, as an industrial robot. I wouldn't look at it as an amateur, you know, drone or whatever. Another thing that I wanted to say, I know I promised to do a presentation, and I'm sorry, my wife got sick, and this week was crazy. But I want to ask if anyone if wants me to do a presentation about you know, like real-time systems, like hard real-time system between hardware, software, you know, speak about the time synchronization, quality of service, why we need that, right? And all of that. So I started preparing it. I just didn't complete it. So I can do that next week if you guys want. And also, I thought maybe we can put a little bit more structure to this meeting by in advance asking, who has an update, rather than me asking it through the meeting and do it like beforehand and prepare like more an agenda to the meeting. So those are like my two things. Yeah.
I think there's a third thing, isn't it? Hint NixOS.
I spoke about NixOS. Oh yeah, the three things. Yeah.
I mean, it's public now that NixOS has FXload and USB-lib now in the main branch.
Oh yes, yes.
Ah,
yes.
now it tickers. Okay.
I totally forgot about that.
I wanted to celebrate that. I mean,
I completely forgot. So yeah, yes. Regarding NixOS, so FXload and libUSB1 is now part of the unstable branch, and that allows me now to take to the next step, which is building the QHY SDK library to NixOS. So that will be like another next step. So I'm kind of thinking what to do, either like the ROS2, camera working, or the NixOS. Both are needed. So yeah, but we are getting there. So that's exciting.
Do you have a copy machine?
A copy machine?
Copy yourself.
Yeah, that's the plan, right? And then, like with all these clones and everything. Yeah, but look, I'm sure, like in a few years, we will have some robots helping us do whatever. It's coming. There's no question about it now. You have the AI, and we have ROS, and now it's being productionized, and it will be super easy to build robots in a few years. Like super easy. Yeah. So, and you probably won't need to do coding as much. Also, like the guys on the video, nice to integrate a PDI controller without knowing all the PDI values, right? Which I doubt this company will focus on to start. Because industrial robotics, you need to know these values. you just do. It's far more complicated than normal drone. The synchronization across components is crucial. I forgot the word that they call it. That I can't remember it. Never mind. My own mind. Yeah. Go ahead.
So where are we in terms of the packaging? So I have my so whatever PC I have, be it a Jetson or Raspberry Pi. How can I make the translation from the Docker container over to some image that's going to run on the Jetson?
Yeah. So the Jetson, the problem with the Jetson and NixOS is that Jetson require a precompiled kernel that only NVIDIA has. So that will not be doable unless someone crazy enough decides to hack the Jetson and whatever, but again, we can still use the Ubuntu Ubuntu image for Jetson and run it over there. Okay.
But it's not the idea that we have. The idea is that we have a Nix package.
Yes. So the Nix package will not support the Jetson Nano.
Okay. So the Nix package, what does it currently support? Can I put the image on the image that's produced? Can I put it on a Intel NUC or Raspberry Pi or?
So right now, there is already an image for the Raspberry Pi 4. Okay. But bear in mind, you cannot even update it right now.
Okay.
So it really was like my first try on building an image with Nix. Okay. The image for the NUC it's in work in progress. Maybe I can try to show you.
And my question, I guess, is so there's a repo in the GitHub with that package definition.
No, not yet. I will put it once it's working. What I'm trying to do right now is having so in Nix there is something that's called Flake. Okay, Flake allows you to have all of your Nix configuration as a Git repository. Okay, and what I'm trying to create now is a single Flake that allows me either to do a build for an image or update the existing system that is running. Okay, or even create a Docker image. Now it's another thing that I think maybe we should do. Okay, and so I'm building that right now. Okay. Yeah, haven't done it before, so I don't know. It should be easy or not. And no, I used before something that called so for the Raspberry Pi, I used something called a Nix generator. But I'm not happy with it at all, and it doesn't allow me to actually build the system, like do an update to the system. It only allows me to do like an SD image. So I'm not a big fan of that. So I need to look at it deeper, how they did everything, and go one layer lower. Which is fine. I mean, in the end of the day, it's a configuration file. It's like code, so it will look nice. I just need to figure out the API for it. Yeah. So I think the end result will be that probably the first system that we will be able to have a fully SD image working will be the Nuke. Okay. Again, all the ARM stuff, unless it's a supported ARM that Nix runs, it's still a struggle, okay? But for that, I think we will have documentation how to install everything, like from downloading the Ubuntu image, putting Docker and ROS2 on it or whatever, and do it from there, okay? The bare minimum will be Ubuntu with Docker, right? So as long as you get like an image with Ubuntu and Docker, you will be able to run everything that we have.
Yeah. Okay, just an update on the Pi 5s. I got the note from the shipper from China, and they postponed it to the end of February, meaning we get it by end of March.
Okay. So an update on that. So the Orange Pi 5 that I ordered, I ordered the 16 gigabyte of RAM. It came with 8.
No.
Yeah, both of them.
You bought from Amazon?
I bought it. No, I actually bought it from that website, not Amazon. The Orange Pi 5 website. Yeah.
Directly from their website?
I think it was there. No, actually, no. You're right. Okay. This was from Amazon. Sorry, this was from Amazon. Yeah, the Rock 5 I got directly from the seller. Yeah.
Okay.
Sorry, I have so many boards. I have like 5 different computers here now. It's a mess.
So just to be sure, my Jetson, I can resell it.
Yes.
Okay.
Yeah. I mean, if you want to use it, go ahead.
I don't have any other projects. No.
Okay. You sure?
Okay.
Like home automation, something?
Wait a second, home automation?
Yeah, why not?
Let's see. Okay. Yeah, I give it a day or two before I put it online.
Yeah. Yeah. So. Yeah, it's getting there. I tried also to use NixOS on the Rock 5B because there is support there, but it didn't boot. And I need to reach that guy to see like
And once, so the PTF or PTZ. So it's another Raspberry Pi box that drives these the actual servos.
No.
How are they connected?
No, the main board is a Pi board, probably.
Okay.
But then there's an extra breadboard that Bojan developed, and it piggybacks 3 drivers, and no, 2 drivers and 3 Teensies.
Okay, so those are the drivers. You mean servos?
No, drivers for stepper motor drivers.
No, so there are no servos involved.
No.
There are no servos.
No.
Okay. Okay, and so it's a breadboard with Teensy boards and motors, driver motors.
Motors, yes. The Teensy boards are for communicating with the Pi board. The Pi board is the processor where the camera feed comes in, and the breadboard that Bojan develops only for driving the rig.
Okay, and how is that coming along? You have any idea how far is it?
Yeah, he has already some samples of PCBs. He tested the Teensies and the communication of the Teensies. So the design per se is there, and the PCBs, the first prototypes are there. But you have to ask him personal to get an update where he's actually standing. I think the last I heard from him was he was testing the Teensies for going with the focuser, because there's a little
yeah, instead of zoom, it's focus, pan tilt focus.
Yes. No, okay. It's a pan tilt focus. Yeah, exactly, pan tilt focuser. But the focus is actually a fixed focus because it's a reflector. The only thing is you can move the back mirror. You can move by a couple of millimeters, and therefore there's a screw inside. And you normally twist that screw by hand. So we attach a NEMA 8 motor, and that had to be step 2, but not with a driver because it's so small that the Teensy itself, with enough power on these pins, can drive it. So that's what he's testing.
So these Teensy boards, so are they part of the ROS, how do you say, because it's multi-IP ROS. How does ROS talk to that PTF? Is the PTF a ROS node?
Yes.
Or yes, it's a ROS node. Yeah. So they're participating in the same network, or it's not on the same machine. It's on a different machine.
It's on the same network. Yes.
Okay, so they have a switch and they talk TCP/IP to each other.
UDP, ROS.
They talk UDP. Okay, and that. So it's the Teensy board that talks UDP, or it's something else. It's like an Arduino on top of the Teensy.
Yeah, we'll discuss it. I'll tell you more about that. We are stepping into that.
Basically, there are 3 Teensies. Just to make it short, there are 3 Teensies, and 2 are for driving the azimuth and the elevation motors.
Okay.
And 1 is for communicating, because it has always all to be in real time and very fast. And we use the simple buses of Teensies, and Teensies are cheap and available. So it is just a cost function evaluation board, let's say. The result is that board. And yes, that talks via network. Now, I think SPI, it will talk to the Pi. I think as an SPI extension.
So when you say the Pi, that's the Pi for the simple tracker. The simple tracker Pi.
No, I'm talking about the PTF. There's also a Pi.
Okay, there's a PTF Pi.
There was a Jetson.
Okay.
Now we skipped the Jetson as
and the PTF Pi. runs ROS. Is a
yes. The idea that the
like a second robot.
Yeah, the PTF. Think about it. It will receive a commands to track an object, right? So there is the output of the tracker, okay? That gives you, here are all the objects that are that I detected, right? Then there will be an AI that will say, hey, this is the object, that is a interest that we want to track, right? And then it will tell the PTF, here's the object that you need to track, right? The PTF now needs to do all the computation of the projection of everything of how to track that object, even if it doesn't receive any more updates anymore. So it needs to act autonomous, right? And continue slewing and tracking the object until it gets like a new command, right? And for that, it needs to be a separate board and a network and all of that. But it will work as a ROS node, multiple ROS nodes.
So what the Pi is telling the controller TNC is where it has to go to.
Okay.
No, just tell it this is the object that of interest. The PTF needs to figure out where to go to and how.
Yeah, when I'm talking about the controllers, the TNCs, the controllers on the PTF. So the Orange Pi just gives the command to the controller where to slew to, and the controller knows where it is. From
the controller
will then look for the fastest path available.
Yes.
Because it
so it's like a ROS goal and action. And are we talking about those ROS2 concepts of goals, targets?
Exactly. Yes.
Fun stuff. Okay.
Yeah.
Okay, that's cool.
Exactly,
okay.
because this is the word that I was missing yesterday, because you want to do coordination here. So you give a target, and then all the pieces are coordinating how to address that, right? So each motor will do his part in coordination. Yes.
Yeah.
Wow. That's that's a nice feature in itself.
Oh yeah, yeah.
Yeah, but not everything is ROS controlled, because there are system intrinsic things that go on that don't need control from outside. So, for example, if you go to the PTF and you control a motor, you do not control the motor via ROS.
Yes, you do. Of course, you do. You have to do it the ROS way. Otherwise, what's the point of doing it anyway?
Yeah, because every sensor, every equipment does its thing at its best.
But that's the reason. That's the reason you put ROS2 with the coordination system behind it. That's the whole point of what ROS is solving.
Yeah, but for me the point is where ROS ends here. For me, ROS ended with the Pi. So the Pi is a ROS node, but not the TNCs on the breadboard.
I'm not sure what you mean TNCs on the board. Again, eventually the motor has 2-3 pins, whatever, connects to the Pi, and then the Pi operates it. And what I'm saying, what operates the motor is the ROS2 node.
No, it's not that simple, because you need extra drivers, because you need more power to drive those motors. Pi does
of course.
Okay?
But the commands that I'm sending from the Pi are coming from a ROS2 node, exactly as like a normal GPIO. Yeah.
I would debate that if we can once, but we are not there yet, so we don't have to go deep in this. But I'd like to discuss this once.
Okay.
I'm quite sure Christian has a different view on that.
I'm sure he doesn't.
Okay, then persuade me. Okay. Other time point. Okay.
So, yeah. Any more from anyone? Or we can for today?
Well, Okay, if there's nothing else, we can stop recording. Ido, if you're okay with this?
Yeah.